Good morning, chemistry students, and welcome to chapters 13 and 14 of your chemistry review. I have a friend here to help me who's eating a whole bunch of Cheerios. Hopefully she won't be too distracting. I'm going to breeze right through this PowerPoint. Again, the link to this PowerPoint is in the description for you to download or for you to view as you study for your exam. Okay? Chapter 13 was over chemical kinetics, over essentially the rate at which reactions occur and how we describe that reaction rate. It talked about the collision theory, where particles have to orient themselves correctly in order to react, and that if we increase the number of particles, we increase the rate of reaction. Of course, raising the temperature is going to raise the rate at which a reaction reacts. We have the transition state theory, where these are the reactants. This is the activation energy here, the transition state and activated complex, and the products. And this here, the change of energy from reactants to products, is the overall net enthalpy. And if the enthalpy is higher, it is an endothermic reaction. And if the enthalpy is lower, then it is an exothermic reaction. And most exothermic reactions are spontaneous, meaning that they happen on their own. Of course, catalyst increases the rate at which a chemical reaction occurs and lowers the activation energy that is needed for a reaction to happen. Consider this diagram where you have the reactants, and they react with a lower energy requirement with a catalyst. And enzymes are biological catalysts. Inhibitors work in the opposite way. We can, of course, describe a reaction and how it happens through the reaction mechanism. The rate-determining step is the rate at which the reaction occurs. And now we're going to move on to Chapter 14. Now, Chapter 14 was a little bit more intellectually challenging. Chapter 14 went over reversible reactions as well as favorability. Now, favorability was quite the thing in order to learn. Favorability is tough. For instance, increase in pressure goes towards a less number of moles. A decrease in pressure goes towards a greater number of moles. So here, if we increase the pressure, there's 2 moles on the left side, 2 moles on the right side. An increase in pressure is not going to do anything. But if we increase pressure here, there's 5 moles on the reactant side and 2 on the product. It's going to go to the product. Increased pressure goes towards less moles. If you increase the temperature, it's going to go towards the product side. If we add in any one of these reactants, it's going to go towards the products. If we add a product, it's going to go towards the reactants. And hopefully you remember those different things. I have a worksheet that I'm going to be giving you which describes this favorability and unfavorability as far as reactions go. And of course, there is the equilibrium constant expression where you write the product over the reactant, and you write the coefficient as the exponent. And K is an experimentally and mathematically determined constant, which you don't really need to use. You just need to know how to set it up. So, I hope you remember all of these things, and I hope these things are pretty fresh for you, even though we did them all the way back, I think, at the end of January or early February. Have a great day, and happy studying for your exams.